Okay, so this is just getting back into the swing of things to make sure I can still do these videos. So this is a sample lecture here, which I will redo. Um, the ideas that I want to discuss here is the idea of a vector, and the two key attributes a vector has are magnitude and direction. And we're going to represent a vector with an arrow, for example, like this. It has a start and an end. It has a tip and a tail, and the magnitude of the quantity we want to represent is the length of the vector. So I'll put that up here. Length of arrow. Length of arrow. And the direction is, well, it's the direction of the arrow. Direction of the arrow. An example of a practical application of vectors is say that you're lost in the woods. So here you are, you're lost in the woods, and over here, let's say there's a cabin, and I tell you that the cabin is 3 kilometers away, but I don't tell you what the direction is. It's pretty useless information. You wouldn't know whether you would want to go 3 kilometers this way, 3 kilometers that way, 3 kilometers this way, or 3 kilometers to get you to the cabin. And so that vector right there, that arrow, it represents not only the distance but also the direction, and this is a special vector that we'll be talking about a lot, which is the displacement vector. Okay, so the displacement vector has two pieces of information associated with it. A length, which is going to be in meters, and a direction, which we can say is some angle theta with respect to the positive x-axis. And so if I superimpose a coordinate system on here, here's a coordinate system like this. That's the y direction. This is the x direction. That's the theta direction. And so I could specify both the length of this vector and the angle, right, like this. I could say that it was a certain number of degrees clockwise with respect to the x-axis, and that would tie things down.